In 1978, a woman named Ruth Caldwell bought a Maytag top loader for her home in Akron, Ohio. She washed clothes in that machine for 31 years. One belt, one lid switch, $40 in parts total. When she finally retired it, she said the motor still ran fine. She just wanted something newer. We bought 5 new washing machines. We ran them until they broke. The results were embarrassing. Not embarrassing for us, embarrassing for the engineers who designed them, the executives who approved them, and the marketing departments who sold them to you as innovations. Here is what we found inside. The modern washing machine is not a washing machine. It is a computer that washes clothes. And like every computer, the manufacturers expect you to upgrade it every 5 years. That expectation is not accidental. It is engineered. Between 2000 and 2006, the major appliance manufacturers went through a wave of consolidation that fundamentally changed what gets built and how it gets built. Whirlpool acquired Maytag in 2006 for approximately $1.7 billion in equity value, with the total transaction including debt reaching roughly $2.6 billion. Whirlpool then closed former Maytag laundry plants across the country and consolidated production into existing facilities. When you see the Maytag name on a washing machine today, you are looking at a Whirlpool product built to Whirlpool's cost targets. The repairman in your grandfather's era knew Maytag as one of the most durable machines on Earth. That machine no longer exists. Then the Department of Energy stepped in. Efficiency mandates with key standards taking effect in 2015 and 2018 set minimum energy and water efficiency requirements for residential washers. That sounds responsible. And it might have been if the manufacturers had engineered their way around the constraint without sacrificing durability. They did not. Instead, they replaced mechanical timers with electronic control boards because circuit boards can manage precise water levels and cycle times that mechanical systems cannot. They sealed drum bearings inside non-serviceable tub assemblies because sealed systems hold tolerances better under low-water, high-efficiency operation. They switched from cast metal drain pump impellers to engineering plastic because plastic is lighter and costs less to run. The per-unit savings from all of these substitutions combined, approximately $12 to $15 per machine. They call it energy efficiency compliance. We call it $12 in savings that will cost you $1,200 in 6 years. They call it innovation. We call it a mechanical timer with physical metal gears and springs replaced by a fiberglass circuit board sitting 6 inches from a humid spinning tub in a vibrating steel cabinet. And the result of all this innovation is sitting in your laundry room right now, counting down to the day it throws an error code and tells you nothing. Let us open these machines up. The first failure point in every modern washing machine is the electronic control board. It accounts for between 35 and 50% of all repair calls we documented. The board itself is a surface mount assembly on an FR4 fiberglass substrate. That is the same basic material used in laptop computers. Your laptop lives on a desk in a climate-controlled room. Your control board lives in a steel cabinet that vibrates at 800 revolutions per minute during spin cycles between hot and cold with every wash, and sits permanently in a room that is often humid. The capacitors on that board swell from thermal cycling. The solder joints crack from vibration. The firmware is proprietary, so even if you identify the failed component, the manufacturer will not sell you the individual board. They sell you a full wiring harness assembly for $300 or more. Labor adds another $150. On an $800 machine, the repairman looks at you and says the 5 most expensive words in the modern economy. It is not worth fixing. Your grandmother's washing machine had a mechanical timer, a physical dial connected to metal gears and cam-driven springs that advance the cycle sequentially. That timer cost almost nothing to manufacture. It lasted 20 to 30 years. It could be replaced by any competent technician in under an hour for $20 in parts. The modern control board replaced it to save $2 to $5 per unit at the factory. The second failure is the drain pump. It accounts for roughly 25% of breakdowns. The original residential washing machine drain pumps were cast metal assemblies with metal impellers. They ran 5,000 hours and longer without significant wear. The modern drain pump uses an engineering plastic impeller made from palm or nylon. The motor bearings are rated for between 500 and 1,000 hours. Under normal use, that timeline collapses to 4 to 6 years. When the plastic impeller cracks, from debris caught in the pump, from thermal expansion, from the repeated stress of spin-up, the machine stops draining. Water sits in the tub. The machine throws a code. The Whirlpool machines throw F21. Others throw E3, LE, whatever alphanumeric combination the firmware uses to tell you something has failed without telling you what. The pump itself costs $40 as an aftermarket part, when one is available. But on most modern platforms, the pump is integrated into the base assembly. Accessing it requires removing the entire tub. That is $500 in labor before the part goes in. On a $500 entry-level machine, the math does not work. The repairman says it again. It is not worth fixing. The third failure is the one that makes experienced technicians the most angry. It is the sealed tub bearing in front-load machines. Multiple class action lawsuits have been filed against major manufacturers over spider arm corrosion and bearing seal defects in front-loading washers. Here is the physics of it. Every front-load washing machine has a drum suspended on a shaft. That shaft rides in bearings. Those bearings experience load, vibration, and moisture every single wash cycle. In any reasonable engineering world, those bearings would be serviceable. You would replace them when they wore out, the way you replace wheel bearings on a car. A bearing cartridge costs $20. The swap takes a skilled technician less than 2 hours. Instead, the manufacturer sealed the drum bearing inside the plastic outer tub assembly. The bearing and the tub are one non-separable unit. When the bearing seal fails, and it will, typically between 5 and 7 years, moisture gets into the bearing race, the bearing corrodes, and the drum starts thumping, then grinding, then seizing. The outer tub assembly on a front-load machine costs between $400 and $600. You need 8 to 12 hours of labor to access it. Total repair cost, $800 to $1,200. On a machine that originally cost $900. The sealed bearing costs the manufacturer $6 less per unit than a serviceable one. In LG's case, lawsuits allege the company knew the spider arm, the die-cast aluminum component that connects the drum to the shaft, was corroding from detergent residue and moisture ingress. The corrosion cracked the spider arm, the drum wobbled, the bearing seal failed faster. The whole system collapsed in a cascade. Consumers got settlements. LG kept selling the same platform. And your front-load machine, regardless of brand, uses the same basic sealed tub architecture. Samsung front loaders, Whirlpool front loaders, GE front loaders. The bearing is sealed, the spider arm is aluminum, the clock is running. The fourth failure is specific to high-efficiency top loaders, the machines that replace the traditional agitator with a low-profile wash plate or an impeller. In the original top-loading washing machine, the agitator was a steel component driven through a steel transmission with steel gears sitting in an oil bath. The machine filled the tub completely. Clothes moved through water. The transmission lasted 30 years. When it finally wore out, a replacement gear case cost $60 and a technician could swap it in an afternoon. The modern HE top loader replaced that steel agitator with a glass-filled nylon wash plate. The transmission gears are plastic. The machine uses a fraction of the water, which means clothes drag against each other rather than floating freely through a full tub. That friction accelerates wear on the plastic components. The agitator vanes snap under load. The transmission gears strip from inadequate lubrication, accelerated by the piece rate assembly practices at high-volume factories. The Whirlpool plant in Clyde, Ohio, produces machines at a remarkable pace. Independent reports document a completed machine rolling off the line approximately every 4 seconds. At that speed, quality checks on critical fasteners become a genuine concern, and whistleblowers have raised questions about assembly practices at the facility. You cannot feel any of this when you load your clothes into the machine. You feel it at year 5 when the wash plate stops turning, and the repair estimate comes back at $300 to $500 on a machine worth less than $400. They call it high efficiency. We call it less water, less cleaning, less durability, and the same price. Now here's the part of the conversation that the manufacturer does not want you to have with your repairman. The reason you cannot get your machine fixed is not because the parts are unavailable everywhere. It is because the parts pricing is designed to make repair economically irrational. A control board that costs the manufacturer $10 to produce is sold through the official parts supply chain for $300. A sealed tub bearing assembly that costs $40 to produce sells for $600. The manufacturer controls the supply chain. There is no competitive aftermarket on proprietary firmware-locked electronic assemblies. Right-to-repair legislation has been advancing across multiple states, with Massachusetts among those debating bills that would mandate parts access for appliance categories. Federal legislation stalled in recent years, despite FTC initiative. Whirlpool includes mandatory arbitration clauses in their warranty agreements, which means the legal path is blocked before you start. So, the machine is designed to fail at components that cannot be economically repaired. The parts are priced to ensure replacement over service. The warranty locks you into arbitration if you push back. And the skilled technicians who might navigate all of this are disappearing. The average age of a master appliance technician in the United States is over 55. For every 5 who retire, 1 enters the field. Within a decade, the people who know how to fix these machines will largely be gone. Some repair companies have already been acquired by private equity firms that keep the local name on the truck and turn the service call into a sales consultation for a new unit. You call for a repair, you get a replacement pitch. So if the machine is designed to die and the service network is designed to disappear, what do? You stop buying the touchscreen, you start buying the motor. There is one washing machine that every experienced repairman we spoke to respects without reservation: the Queen TC5 or TR series top loader. Queen is built in Ripon, Wisconsin by Alliance Laundry Systems. The company has operated outside the publicly traded mainstream appliance industry and has not been subject to the same quarterly earnings pressures that have driven cost-cutting decisions at the major brands. The Queen top loader has a steel transmission with steel gears. It fills the tub completely with water. It has a mechanical agitator. It does not have a touchscreen. It does not have Wi-Fi. It does not have a main control board managing 17 sensor inputs. It has a dial. Consumer Reports consistently rate Queen at the top of their reliability rankings for agitator washers. The machine's repair rates in independent surveys run dramatically below the industry average for mainstream brands in the same ownership window. The machine costs approximately $1,400 to $1,500, depending on model and retailer. The 10-year total cost of ownership, including the warranty and the near-zero repair rate, runs well below what a mainstream brand washing machine will cost you over the same decade when you account for replacement cycles and repair attempts before you gave up. The Queen is not cheaper to buy. It is dramatically cheaper to own. If you are not in a position to buy a Queen, the next honest recommendation is the simplest Whirlpool or Maytag top loader you can find, with a mechanical timer and a traditional agitator. Look for a knob. If the panel is entirely flat touch controls, walk away. The fewer electronic inputs, the fewer failure points. Avoid the VMAX platform, which has documented pressure sensor failures. Avoid any front loader with a sealed tub bearing unless you are prepared to replace the machine in 7 years. If you own a washing machine from before 2005 that is still running, do not replace it. That machine has a steel transmission, replaceable bearings, and a mechanical timer. It is built from components that are superior to anything you can buy new today. Maintain it. Find a technician old enough to know it. It is not an old appliance. It is an asset. Consumer Reports 2025 reliability data places Kenmore at the bottom of the rankings and Frigidaire near the bottom as well, with Samsung and Whirlpool scoring in the middle of the pack. These are not passing grades. Dozens of CPSC recalls have been issued for washing machines over the past decade. Whirlpool, LG, and Samsung have each been among the most frequently recalled brands. These are not edge cases. This is the industry. Here is the verdict. Mechanical beats digital. Steel beats plastic. Repairable beats sealed. Simple beats smart. Buy the machine that has fewer things to fail. Own it for 30 years.